In this lesson, we're going to be talking about another routing protocol. This routing protocol is OSPF, or Open Shortest Path First. OSPF is actually based on the idea of having multiple points in your network and what points are connected to what other points. And it's really a similar idea to how your GPS works. So your GPS actually has a map of what points are related to what other points, and based on that, it builds this structure of how to get from one place to another. That's similar to how OSPF works. Now, OSPF is a link state protocol. A link state protocol is really, as I said, all about communicating information with the people around you about who you're connected with. Once you are connected to these people and you've exchanged all of this information, you can build this map of basically how to get to everywhere. OSPF is actually an interior gateway protocol, and so the routing is all done within a single routing domain or autonomous system. So I've got a packet capture here, and let me get into a little bit more detail around OSPF. So the first thing that happens when a router comes up is it's going to send a hello packet to all of the people around it. So you can see the destination here is actually a multicast address, and I'm going to send a hello packet out, which says, I am awake, I'm connecting to other people around. So it's an initial connection. It also becomes a keep alive. Periodically, hello packets will get sent out to the network. We've got a designated router here of 192.168.170.8, which is where this message is actually coming from. So we've got a bunch of hello packets here, and then we see a number of DB description packets. So what's a DB description packet? Well, a DB description packet actually defines the topology of the network from the perspective of each individual router. So these are the people that I am connected to. It's the topology description that gets sent out. So this is the contents basically of my database. So I am sending those messages out. You can see there's a couple of routers here that are sending out the DB description messages. We pop one open and we can see all of the information that gets sent. We've got the OSPF header, and it tells us it's the OSPF version 2, and the message type is 2, which is a DB description message. The source router is 192.168.170.3, and we've got the area ID. As I said, this is a protocol that's designed as an interior gateway protocol, and it's based around the idea of routing areas. So this is the area ID here, and it's 0.0.0.1. Now we've got the DB description portion of the message, and now we've got the link state advertisement headers, and we've got a link state ID and an advertising router. We've got some options, and it tells us that external routing capability is on. And we've got a number of LSA headers. So we've got another link state ID of 80.212.116.0. So that's a network that we know about. And we've got several others here as well. So 148.121.171.0, that's another one that we know about. The LS age here is 2 seconds, and periodically an LS request will get sent out saying, hey, I think my topology database may be out of date. Could you get it updated for me? So we're sending out a link state request, and what we will get back is LS updates. And you can see the OSPF header here in this LS update message and the LS update packet. We've got a router link state advertisement, and you can see that the link state ID here is 192.168.170.8. It's a stub area. So we've got the IP network is 192.168.170.0, and the link type is a connection to a stub network. If the router thinks its database is out of date, it's going to send LS requests and then get LS updates in response. And then we're going to send out acknowledgments to these updates saying, yeah, I got it. Again, all of these routers with these updates and advertisements are responsible for maintaining this database and building a topology map within themselves so they can quickly calculate the quickest way to get from themselves to any other point on the network based on where all of the other places within their network area are. All of the other routers and the networks that belong to those routers. The open shortest path first is based on the idea that I've got a route in mind before I even send the message. So it's not like other protocols that say, I'm going to send it out to the next router and just get it a little bit further on towards my goal. With a link state protocol, I've got a map in mind, and again, it's very much like a GPS. The GPS knows how you're going to get to where you're going from the point that you start. And a link state protocol has this same idea because they're both kind of based on Dijkstra's algorithm, which is this open shortest path first network topology concept. You're going to figure out the path that a particular packet is going to take before you even start sending it. If something happens along the way, then the route would get recalculated and the routers along the path would make adjustments as they went. But basically, you're sending it to the next router along the way that's going to be the quickest way of getting from point A to point B and getting that message there as quickly as you can. So that's the open shortest path first routing protocol.